Let us solve this problem from integral calculus. The value of this integral is which one? The first, the second, the third, or the fourth one? If you still remember, we have one property of integral, which is this one. Integration from 0 to a f x dx is the same as integration from 0 to a f a minus x dx. We shall use this property of integral for this particular problem. So let's do it. Solution. Integral I is equal to integration from 0 to pi by 2 sine cube x dx divided by sine x plus cos x. We mark this one as equation 1. This implies integral I is equal to. Now use this property. We have sine cube pi by 2, which is a, minus x dx divided by sine pi by 2 minus x plus cos pi by 2 minus x. Implies integral I is equal to 0 to pi by 2. Now look here carefully. Let's write first like this: sine pi by 2 minus x whole thing cube dx divided by sine pi by 2 minus x plus cos pi by 2 minus x. Alright. The value of sine pi by 2 minus x is cos x. Sign will change into cos because we have pi by 2, right? And this one is positive because pi by 2 minus x lies in the first quadrant, and in the first quadrant all the trigonometric functions are positive. That's why cos x is positive in this case. We have with this cube dx. In the same way here, since we have pi by 2, then sine will change into cos x, and again it will be positive because pi by 2 minus x is positive in the first quadrant. Plus, now here cos will change into sine. We mark this one as equation 2. Now we add equation 1 with equation 2. Adding equation 1 and equation 2, we get from equation 1 on the left hand side we have I, and also from equation 2 on the left hand side we have I. So if we add the 2, we get 2I, and on the right we have 0 to pi by 2 sine cube x dx divided by sine x plus cos x, plus 0 to pi by 2 from equation 2 cos cube x divided by sine x plus cos x dx. This implies 2I is equal to, for these two I can simply write integration from 0 to pi by 2 sine cube x plus cos cube x dx divided by sine x plus cos x. Now, we know that a cubed plus b cubed is the same as a plus b times a square minus ab plus b square. So now we use this formula. If we compare this one with this, our a is sin x and our b is cos x. This implies 2i is equal to 0 to pi by 2. We have sin x plus cos x times, let me write it here, 2i equal to 0 to pi by 2 sin x plus cos x times a square, that is sin square x minus ab sin x cos x plus b square plus cos square x dx divided by sin x plus cos x. These two get cancelled. We get 2i to be, now look here, sin square x plus cos square x is equal to 1. 1 minus sin x cos x dx. Now we also know that sin 2x is equal to 2 sin x cos x. So from here it implies that sin x cos x is the same as half of sin 2x, right? So this implies 2i is equal to integration from 0 to pi by 2, 1 minus, in place of this one we write half sin 2x dx. Now integrate. Integration of dx minus half integration from 0 to pi by 2 of sin 2x dx implies 2i is equal to integration of dx, we have x, limits of integration is from 0 to pi by 2, minus half integration of sin 2x is minus cos 2x by 2, minus with minus we have plus, cos 2x by 2. The limits of integration is from 0 to pi by 2, implies 2i is equal to, now put the limits of integration, pi by 2 minus 0 plus half cos 2 times pi by 2 by 2 minus cos 2 times 0 by 2. This implies 2i is equal to pi by 2 plus 2 get cancelled, cos pi is minus 1, right? So we get minus 1 by 4. 2 times 2 we get 4. And here plus with minus we have minus, cos 0 is 1. So 2 with 2 we have 4, minus 1 by 4. So this is equal to pi by 2 minus 2 by 4, right? Pi by 2 minus 1 by 2. 2 with 4 get cancelled, we get 1 by 2. So from here if we take LCM we get pi minus 1 by 2. See, 2i is equal to pi minus 1 divided by 2. So this clearly implies that I is equal to pi minus 1. If we take this 2 to this side, we get 2 times 2, that is 4. So our integral I is equal to pi minus 1 by 4. Pi minus 1 by 4. 3 is the correct option.